Today I'm going to talk about what I've been working on, and that's using potassium iodide stripping solution for gold-plated pins. I have been working with a typical recipe of 400 milliliters of water, 40 grams of potassium iodide, and then 10 grams of iodide crystals. And I've had pretty good luck with the fresh solution, but trying to use the recycled solution has been a real challenge trying to get it energized. So I had enough free iodine to be able to strip pins. Here's an example of some stripped gold-plated pins. And if I'm using too basic or too acidic of a solution, which strips really well quickly, I end up with all these hydroxides, which is a real mess. And you end up with a big container of this hydroxide goo. It's all the base metals. Rather, if you use, these are individual 400 milliliter batches, probably 13 or 14 of them here, till I finally went over to an alkaline type solution. And for a reasonable amount of pins, maybe 200 grams worth. These are probably 300 grams worth of pins, and these are about 200 grams of pins. But anyway, you can see there's a considerable reduction in the amount of dropped metals. Hopefully, the majority of this is gold when using a pH of 8 when you're doing your stripping solution. And so now I'm going to run through and kind of show you the process I've been working on. Here's the old lab setup, and this is the typical filter funnel. And you can see I just did a batch here, and there's just a small amount of filtered participant. And then there is a little bit that went through the filter here, but that's okay. So the container that I've been using, and setting ingredients, of course, would be formic acid, hydrogen peroxide, and potassium iodide, and the potassium hydroxide. So let's look down here once, and I'll show you the process. So basically, I start off with my pH 13 solution. I add 3.5 milliliters of formic acid to get a pH of 2. Did I get a purple color? Generally, sometimes I usually get a purple color, but if I want to strengthen it up, I could either add hydrogen peroxide, 12%, 2 to 4 milliliters. And if that didn't really do it, then I throw in some potassium iodide and then make in situ conversion from potassium iodide into free iodide, similar to when you first make the recipe of taking Ki and then converting it, get it acidic, and then converting it to iodide crystals, and then you got to dry and store the crystals. But in this case, we're doing it right in the beaker before we actually start stripping. So this way, you don't even have to have your iodide crystals through the nose to get them, but you can actually make them right before you do it. And then to activate it, you add your hydrogen peroxide to it. And then once you got what you think is a good full strength recipe, you'll go in and you got a good deep purple color, meaning you've got free iodide solution. Then you raise the pH to 8 for stripping, and that cuts down on your stripping or the dissolving your base metals. And usually make that conversion for 450 milliliters, about 2 grams of potassium hydroxide to get it up to pH 8. You strip your gold. Is your solution turning dark tea color instead of purple? You're losing your free iodide. If that's the case, is everything stripped? Yes, you're done. No, maybe you want to go in and you can either end it, or you can go in and try to refreshen your solution by adding more formic acid. Usually about 1.5 milliliter will usually run you up to about a pH of 2. And especially when you have a weak solution, it's an unknown strength of iodide when you finished up, because every time you do a cycle, you're always washing stuff down, so you're diluting your mix. So this iterative process allows you to strengthen it and run through the same cycle. So you take it back acidic to a pH of 2. You get your purple color. You do your additives, hydrogen peroxide or Ki. And then you roll through and you back up the pH of 8 by the addition of 2 grams of, and you do your stripping, and you're right back and rolling again.